Welcome to our QuickControl tutorial video series. This tutorial video will show you how to use digital IOs in your QuickControl application programs. I have 4 IOs defined, 3 inputs and 1 output. Here's the wiring diagram. IO1 is a home switch, which is normally opened. IO2 is a momentary switch, which is also normally opened, and IO3 is a option switch that will allow to select for a secondary function. IO4 is an LED indicator, which is set up as an output. We'll first start off by renaming our IO by going to the Programs menu, IO names, and we'll rename IO1 to home sensor, IO2 start switch, 3 the first command would be a digital input filters command. The digital input filters command allows for a filter to be applied to individual IOs or to all IOs. It helps filter out switch debouncing where a single input can trigger multiple times. So we'll apply a 10 millisecond filter constant to all IOs. Next, we'll configure our IO using the CIO command, configure IO command. Note all IOs default to inputs on power up. So we'll first configure our first 3 IOs as inputs by selecting the input. So go ahead and copy, paste, Control C, Control V to add additional CIO commands, and I'll update the following commands by double clicking. And the fourth CIO, I'll set it as an output and I'll set it high. Setting it high will ensure that the LED indicator is off on startup. Next, I will add a wait on bit edge command. I'll set it to IO2, which is our start switch, to low. The wait on bit edge command monitors an input's edge transition. A falling edge would be a high to low, and a rising edge would be a low to high. This prevents an operator from continuously holding an input on. Next, I'll add a velocity command, a velocity mode program mode, and command the motor to move 100,000 counts per second and a velocity of negative 32,000 counts per second. I will give it a condition to stop when the home sensor is low. Next, I will add a register-based command, a register-based move command in RAV, and I will select register 4. Register 4 records the last position, the last motor position when an IO was triggered. So when the motor is executing the VMP command and the IO1 home sensor is triggered, that position will be stored to register 4, and so the RAV will then command the motor to move to that exact position. Then we'll add a ZTP command, which sets the target and actual position to 0. Once the position's been set to 0, then we're homed. And from here, we're going to load a new program using the load and run program command, LRP command. I'll double click the program button, and I will add a new program, and I'll call it main. And if you notice in the program list, it adds the new program, main1. And in main1 program, I will add another wait on bit edge command and select the same IO2 start switch when it goes low. So this when it goes from high to low, a falling edge. Then I will command the motor to move using the MET command, which is an absolute time-based move, and I'll have it move to 50,000 counts. Ramp time of 100 milliseconds and total time of 400 milliseconds. And I'll copy and paste and insert two additional move commands. The second command, I'll command it to 75,000. And the third command to 120,000 counts. And then I'll add a loop. I'll add a jump command that will loop this program. And between moves, I want a delay, so I'll click the move command, click the add button, go to the delay command. I'll add a delay of 1 second between each command, so I'll copy paste. And what I want to do is before each move, I will turn on the LED indicator. So I'll click the add button, and I can turn on the IO4 by setting it low using the clear output bit command. So before each move, I will clear the IO low. And then after each move, I will set it back high using the set output bit command, which will then turns off the LED indicator. So I'll go ahead and download this program. We can see that the program is running. The current state of the controller is program run. So I'll enable debug so we can see the program. And we're currently waiting on IO2 to go low. It's highlighted in yellow. So I'll go ahead and trigger IO2 low. And we can see that it's waiting for the next transition. We're now in the main1 program. So I'll go ahead and trigger IO2 low. Uncheck debug, So I'll go ahead and copy one of these blocks after the third move, and then I'll give it a position of 0, absolute position of 0 to go back home, and I'll give it a longer total time, 1000 milliseconds, and I'll go ahead and download restart. I'll hit debug. I'll go ahead and trigger IO2. Now in main one program, I'll add a condition where if IO3, the option switch, is low, I'll go ahead and run a different function. So I'll go ahead and add a command below the wait on bit edge command, a jump on input command, JOI, and I'll enter a label of option 2, set the condition to low, set the condition to IO3, state low. So I'll go ahead and click OK. And at the end of the program, I'll add a load and run command and enter a new program, and I'll call it option 2. So now when IO3 is low, it'll jump to this option 2 label, which will run option 2 program. And in this program, I'll command the motor to move to 50,000 counts. In 1 second. I'll then clear the I/O, turn on the LED indicator. And then I'll move it between 2 positions. So copy, paste. And while my option 2 switch is low, I will repeat these 2 moves. When the option 2 switch is no longer low, I will then set the IO4 high, turn off the LED indicator. I'll then move back home using the MAT command, give it a position of 0. And then I will load and run our main 1 program to jump back to the main 1. So I'll go ahead and download. I'll check debug, and I'll go ahead and hit start switch. I'll activate option 2 and hit the start switch. This concludes the QuickControl tutorial. For questions or comments, email us at support@quickservercontrols.com, and for more information, visit our website at quickservercontrols.com.